Okay, so I'm doing question 3, and it asks, a bead slides without friction around a loop-de-loop. The bead is released from a height h equals 3.5 r. A, what is the bead speed at point A? And B, how large is the normal force on the bead if its mass is 5 grams? So since there's no friction acting on this system, we know that there is a conservation of energy, so the initial energy is equal to the final energy. So for the initial, we have when the bead is up here, and there it has gravitational potential energy, which is mgh naught, and then the final is at point A, and at that point it has gravitational potential energy and kinetic energy. So we have mgh final plus half mv squared. So obviously you can see there's mass in every single one of these, so mass can be divided out, and then you're left with g times h naught is equal to g times h final plus half v squared. And so the height originally is 3.5 r, and then here it's at the top of the circle, so we know that's the diameter, which is 2r, and then it equals v squared. And then once you solve it all out, you should get that v is equal to the square root of 3gr. And then for part B, they ask how large the normal force is if the mass of the bead is 0.005 kilograms or 5 grams. So here's just a little diagram of the forces. You have mg and you also have the normal force. And so if we write the equation of our forces, we have mg plus normal force is equal to mv squared over r. And then when we solve for normal force, we'll get that we'll get m times v squared over r minus g. And then you can plug v in, and we don't know r, but when we plug v in, the r's will cancel. And then you will get 3g minus g, which is 2g, and then when you multiply 2g times 0.005 kilograms, you should get 0.098 newtons.